Okay, this is section 9.2 on proportions. Back to Benford's law. So this is a test for proportions, and we are wondering, okay, and this is especially apropos as tax season approaches, that there's this test called Benford's law, and it states that the distribution of first digits is not uniform. So if you're making up numbers for your taxes and you try to evenly distribute, like, oh, this will start with a 6, this will start with a 3, this will start with a 9, and make it even distribution, you are going to be looked at with suspicion, because about 30% of the numbers should start with the digit 1. So we're wondering if, so we're trying to figure out if we should be suspicious. So let's state in our state, let's always set up what P equals. So we let P equal the true proportion of expenses that begin with 1. True proportion. We have not collected our data yet. True proportion of expenses starting with digit of 1. True proportion of expenses. Okay, so true proportion of expenses. Okay, so now H naught is going to be our statement of no difference, meaning that P, we're going to assume that the actual population proportion is about 30%. And what we would like to show is that P is it greater than or less than 30%? Okay, it's actually not equal to, because we want to just know if we're really far away from 30%, but in either direction it would be suspicious. So if it's not clear in the problem statement of which direction, make it a two-sided test. And that's going to change how we find the p-value. And you'll see it when I'll draw a picture in a second, but it makes it more likely, because not equal to, we could be in either direction, greater than or less than. So here we're all set up. So our plan, the name of our test, I want you to practice getting that, is called a, it's always going to be one sample, because we're taking from one population. In chapter 10, it'll become 2 sample. So that's why we have to be really clear. A 1 sample, Z or T, everything is Z today. They're proportions. That's the only option for proportions. Z test for P. So 1 sample Z test for P. That's the name of the test. The random and independent condition, we're just gonna, those are met. The normal condition is the most important. So I just want to write here that it's N P naught and N1 minus P naught have to both be greater than equal to 10. And you have to show the numbers. So it would be, let's see, 300 times 30% is 90. .3, so that's greater than 10, and then 300 times 7, about 70%. 1 minus 0.301 will give you about 209.7, and that's also greater than. So you have to plug in those numbers to show. Okay. So we are ready. That means our sampling distribution of p hats will be approximately normal, which lets us do this. So now we collect our sample and we get 68 out of 300. So we're like, how far away is that from 30%? Or is it? So let's put it in decimal form. Otherwise, it's really hard to tell. 68 out of 300. So that gives us 22.7%. Okay. It seems it's 8% away, but until we know what the value of the standard deviation is, we don't really know. We need to know how many standard deviations away it is to figure out if it's likely or not. We can't just look at these numbers and say, oh yeah, That seems far enough away. We can prosecute this for tax fraud. So we're going to find our test statistic z. We're going to take that 0.227 and subtract it from 0.301 and divide by the number of standard deviations, which is 0.301 minus 0.301 over 300. We're going to make sure we can do that carefully on our calculator to get negative 2.79. Is that unusual? Yeah, almost 3 standard deviations away. We're a little suspicious. So let's figure out what the probability is. And I really want you to draw this picture, because what we care about is, this should be very small here. What is the likelihood of getting negative 2.79 or less? Or on the other extreme, 2.79 or greater? Because those are both far enough away for us to conclude that it's not equal to 0.301, that our population proportion. So when you do your p-value, please don't forget to multiply by 2. So you're going to do 2 times normal CDF. And now you have options about the range that you use. If you look at the area, it's totally symmetric. So you can go from negative infinity to negative 2.79 or 2.79 to infinity. Don't make the mistake of going from like negative infinity to 2.79. You see how that's going to give you like an area greater than 50%? If you go from negative infinity to 2.79. So pick your direction. I'm gonna say 2.79 to infinity. It doesn't really matter. They're the same area. And so you get 0.0026, but you have to double it. And so you get 0.0052, which is a 0.5% chance, a 0.5% chance. So are we gonna reject the null hypothesis? Yes. So we write it, since p-value is a less than alpha, we reject H0. So there is convincing evidence. There is convincing evidence. The proportion of expenses is not 30%. The proportion of expenses that start with a 1, the proportion of expenses beginning with 1 is not 0.301. And then the implication is that AJL should investigate for tax fraud or